now. Okay. So we're group 8, and I'm going to be going through 1 through 3. So I'm going to share my screen real quick. So I'm going to be showing how we calculated the volume, density, and the average density. And so here is my data. So for number 1, how I calculated the volume is I used the data that was given, length, and the formula is going to be length times width times height. And I converted millimeters to centimeters for all of them. So because like the formula density is going to be measured in grams per centimeter cube. So in order to do that, you have to divide each number by 10. And that basically just moves the decimal place over one to the left. So when I did that, I did the multiplication. I get 4.31 centimeters cubed for the first one. And for number 2, calculating density is density equals mass divided by volume. So I'm going to plug in the mass that's given here, and I'm going to divide it by the volume that I get. And it's going to give me 2.71 grams per centimeter cubed. And then for number 2, same thing, length times width times height. We're going to move the decimal place over 1, turn it into centimeters, and then multiply, and we get 8.74 centimeters cubed. For number 2, density, 23.7891 is our mass, divided by 8.74, and you get 2.72. Number 3, same thing, decimal place over, multiply, 14.9 centimeters cubed, density, mass divided by our volume, 2.71 grams per centimeter cubed. And then number 4, same thing, we got 8.8 centimeters cubed, and that's 50.999, and you get 2.71 grams per centimeter cubed. For number 3, calculating our average density, we're going to add all our densities that we got. So there's 4 of them, so we add the 4, and then we're going to divide it by 4. So it's going to be 2.71 grams per centimeter cubed as our average density. So with that, that's 1 through 3. I'm going to pass it over to Duke so he can show us our graphs.
All right, I will be taking over and talking about the graph with the calculation that Jose got earlier for me. I'm going to be sharing my Excel. So here's the here's the chart with all the numbers that we use, the mass, the volume, the density of the number that from the calculation earlier. And then the graph is the mass versus volume, is the name of the graph. So the main 2 components of a graph is the volume, the centimeter cube is a unit of it, and the mass, which is gram, is a unit. I have the volume on the y-axis and the mass on the x-axis, and I use the point plot graph for this one. After that, I have include a trend line, and also the equation and the r square of the line. So the equation of the line is that y equals 2.7105x plus 0.0203 with the r square of equal 1. So that should be the graph right now. We're gonna move on with the question 1. So the first question asks the value and compare to the average value of the density. So the value of the slope is 2.7105, and our average density value is 2.71. They are a little bit different due to the Excel found like the best fit line and the average number for the graph, while we do the average of all 4 trials differently because we have round up the number to 3 sig figs, so the number is slightly different.
Okay. So for number 2, what might be some sources of errors that could have occurred? So the first error that could interrupt like the whole calculations that we agreed on would be equipment. But I mean, what we mean by equipment is that whenever the data was given to us, there may have been like a conflict with the equipment when it was measured. So sometimes the scales can be a little off, or if you don't let it balance out enough, it'll throw off your numbers by a little bit. And then another thing would be our calculations. So the mathematics that we did, and sometimes we multiplied a number wrong or we entered a wrong number, and that could throw off pretty much the whole calculation. And then another thing that I messed up on when I first did the calculations was unit conversions. So the first time I went around it, I didn't convert millimeters to centimeters, and the reason that throws everything off is because the number is like really small, and density isn't really measured in grams per millimeter cubed. It's measured in grams per centimeter cubed. So converting that to centimeters is really important. So yeah.
All right, question number 3. So when we look at the fall values, how close are they to each other? So for me, they're different from each other within the 100th place in the decimal value.
Mm-hmm.
Okay, question number 4.
Yeah, so for question number 4, I'm going to share my screen again to show the data that we got. So the question's asking, the rectangular block is aluminum with a known density of 2.710 grams per milliliter. Calculate the percentage error using the slope of the line as experimental value for density. Discuss how you did the calculation. So once again, I'm going to show our data for us. So the formula for percentage error is the absolute value of actual minus the experimental divided by the actual and multiplied by 100. So entering the data that was given in the equation, the actual is 2.710 minus 2.7105 divided by the actual 2.710 multiplied by 100. So our first step is to do 2.170 minus 2.7105. So basically the top, you have to subtract them first so you can get the proper sig figs on the top. So when you subtract them in the calculator, you get 0.0005. And in order to get 3 sig figs, because there's 3 sig figs when you're subtracting it, you have to add 2 zeros on the end. So you get 0.000500. So once you do that, you put that on top, the number that you get, and then you divide it by 2.710 and you multiply it by 100. And then you get your percentage right here. So with that, that's our calculations for group 8. Thank you.